And what I'm going to do up here above it is I'm going to draw where the object is relative to the spring. So in this first one, we know the object is, well, I don't want to draw it like that. I want to draw it like looking like it's stretched out. So that's where it is at 0. And it makes it to its highest point at 0.5. And this is when it's 1 meter above the ground. And then at 1 second, it's, again, then at 1.5, it's back up here. Now, I'm not going to draw all of these, but in the middle, I'll draw it right here. It's in the equilibrium position. So it's at 0.75 meters. And of course, it's like that here, and it's like that here as well. Okay? So what I'm choosing to do is I'm choosing to say that that's 0 for gravitational potential energy. And we can set that wherever we want. Now, you don't have to do this way, but there's nothing wrong with doing it this way, because we're allowed to set the reference level, and this is the lowest point in the problem. So this is a 0, and I'm going to kind of write this here, that gravitational potential energy is 0 here. Now next, I'm going to go over to this next line here and put another line in, because this represents where the elastic potential energy is 0. The spring is at equilibrium. Okay, everybody good so far? So here's what we need. We need that value for K, because when the object is at the red points, its elastic potential energy is at a maximum. Doesn't matter whether it's bottom or top, the elastic potential energy is maximum. We need to know how much elastic potential energy there is at the maximum. And we know that that's going to be equal to 1/2 K times 0.25 squared. So you guys have just spent the last few minutes figuring out what K is. Can somebody tell me or put it in the chat what K is? All right, so Matt got 1.57. Does anybody agree with Matt? Wow. Somebody else got 4.93. Alex? It's m over k, 2 pi times the root of m over k. Would be equal to 1. Yep. So many of you got 5. Let's go with 5, okay? I mean, I know you got 4.93, but won't it be easier if we just use 5? So go ahead, 1/2 times 5 times 0.125. This is the amount of elastic potential energy the object has at all of the peaks. So I'll just take a moment, calculate it out. All right, no worries. Look, I do it all the time. I've been making mistakes like crazy today, so clearly I'll let one of you make a mistake for a change. Somebody throw me out what this value is going to be. I got at least one person saying 0.3125. That's joules. I'm assuming that that's okay. So now what this means, .25 squared, is that not what .25 squared is? Oh, 0.25 squared is 0.625. Oh, Mr. Shelton. I should just stab myself in the brain. I should just do it. It's just not happening today. 0.156. At least I'm recording this so that we can definitely throw down that Mr. Shelton didn't know that 0.25 squared is not 0.125. I have to say it out loud because my iPad is not recording the session, and so everyone's going to wonder why I erased it and put something else there, so now they know. So it is definitely, Michelle, I'm going to put it in the calendar, so next year, yeah, I'm not coming to school that day. So, at all of these places where we have a red X on the screen, there's that much potential energy. Does that make sense? So, in the places where it's at the bottom, that represents all the potential energy it has. So, I'm going to make this line and say that's 0.156 joules. That's how much potential energy it has right there. Does that make sense? And it's going to have that amount of energy when it's here as well. So I'm just putting those points on the graph. Next, let's look at the gravitational potential energy, because we have gravitational potential energy any place where there is a green X. Right? Gravitational potential energy in all of those places. In the blue line green dots or green X's, the amount of gravitational potential energy is going to be m g h. Right? The height is 0.25 from the lowest level it was at. So how much energy is this? I've got to let you do it. If I do it, we're going to be in trouble. So that means that any place where there's an X, that's how much gravitation. Any place on the blue line where there's a green X, that is the only energy the object has is gravitational potential energy there. So I got to move this because I don't have space. So put over here 0. What'd you say? 3 what? 325? Okay. So that means I have to put a green dot here, because that's how much energy I would have at these spots. It's more than 0.516, it's 0.3125. And lastly, when it's way up high, it's got gravitational potential energy equal to mg, where h is now 0.5, which I would assume is just twice as much as I had before, so that's 0.6, right? 0.625, because I'm twice as high. But also, at all of these spots, I have elastic potential of 0.156 plus 0.625, so that's going to be like almost 0.8, which means I'm going to have a dot way up here for those. So what does that mean for our graph? Something like that. With asymptotes at the 0.156 at the bottom and 0.8 something at the top. I know we're totally going to get yeeted out of this. And Lauren says, can we go over the practice quiz really quick before we have to leave? No. because there's not enough really quick left. I could immediately restart the session if you really want to go over the practice quiz. So for anybody who does want to come for the practice quiz, I'll be happy to go over it real quick. For the rest of you, I hope you have a wonderful, wonderful day. I am looking so forward to seeing you all tomorrow. And please go outside and play a little bit. I will post this video, of course,